have actual numbers, but we'll see if we can make this work. So let's say we got, so here's the ground. We know the airplane is 6 miles above the ground. Here's the plane.
Do you want the number?
We call this X, we call that S. We do.
Please draw a.
I'm not going to draw a plane.
I'll draw it for you.
No.
Toss me the money.
Let's go with. Well, here's what was given to us. S was decreasing at a rate of 400 miles per hour, so ds dt was negative 400.
What number is this again?
This was from example number 4. This was in our notes. It also said S was 10 at that moment. We did Pythagorean's theorem and figured out that xn was 8 at that instance. And then we also determined, we worked through the problem, we got dx dt was negative 500 miles per hour, right? In our notes?
Yeah.
Now, when we answered the question, though, what was the speed of the airplane, we said positive 500 miles per hour. Okay. But that was negative 500 as far as dx dt because the plane was headed that direction right there. Okay. All right. So I'm going to change the question here to what is the angle of or how fast is the angle of elevation to the plane changing? How fast is the angle of elevation from the ground to the plane changing? So when I ask that, okay, here's our ground. Our angle of elevation would be this angle that's located right here. So if I want to know how fast that is changing, I want to find d theta dt. If I want to know how fast the angle of elevation is changing. So we probably need to write some sort of an equation that involves a theta. What might we do? What's that? How would theta end up being in that Pythagorean theorem?
If you look at it, it's divided, and it's a 90-degree angle from the ground.
Isn't it just a trig function?
Yeah.
Use a trig function.
But
Is
then
it
you
nice
just
to
have
use
the
the
sine
sine?
But what if you just change where you're looking from at the ground? Then it's always 90 degrees. Ground, if you move the point that we're looking at, 90 degrees.
Angle elevation from right there.
Okay, so that's what you should have said.
Yeah, I know. I did make that very clear.
For John.
We will have to use a trig function.
Yep.
What if you do, I don't even necessarily have to.
Yeah, you could do that.
Yeah, that's what I was thinking.
Triangle.
Will that make?
I know this is 6, right?
Yeah.
Yep.
And I know that's 10.
Yeah.
So the sine of theta equals 6 over 10.
That's points.
Yeah.
Yes,
I
we
have that. Or actually, the sine of theta equals, because that's changing, 6 over s. So then if I differentiate, I get cosine theta d theta dt equals, if I visualize this as 6s to the negative 1, I get negative 6s to the negative 2. Because instead of using a quotient rule right here, I could just rewrite 6 over s as 6s to the negative 1 power.
Yeah.
That way I don't have to use the quotient rule. ds dt.
Sorry, granted about it.
Now, I'm not quite ready to just plug in numbers here because, yes, I know ds dt. Yes, I know what s is. This is what I'm trying to figure out. I don't have theta yet, but I could definitely figure out theta. Because at this very moment here, this was 6 and this was 10, right? So the sine of theta at this very instance is 6 over 10. So if I inverse sine both sides, I could get my angle. I'm in degree mode, so I'll get my answer in degrees, which is fine. That'll be more meaningful to you. Inverse sine, 6 over 10. 36 point, and there's a bunch of decimals. 869898. I know there's more, but that'll be pretty accurate, just even going that far. Then I could go ahead and plug in everything that I know and figure out how fast the angle of elevation is changing.
Can you plug in 10 for the S? Because it's not instantaneous.
You can plug in 10 for the S, yes.
You can.
Yep. So I'm going to go to the next page, 869898. Cosine 36.869898 times d theta dt. Negative 6 s to the negative 2. S is 10. The SDT was negative 400. And then I can solve this for d theta dt. That is 1 over 100 times negative 400 would be negative 4 times negative 6. I believe you get 24 then over there.
Yep, you could.
Cosine of that answer. Yeah, I know, it's silly of me. We already know what it is. It'd be 8 over 10. Because if this was 6 and that was 10, it's 6, 8, 10. Cosine.
Why did you just do that in
So,
I mean, technically it's 0.79999, so.
Nope.
technically, because we rounded, it's not.
That's true.
But yes, yeah. So you're gonna end up
Keep
getting.
those whatever's in your mouth. Okay. Yeah, you tell. That's right.
Thanks, guys. Thank you.
Yeah, you try it out there,
You
kid.
guys are so nice.
You try.
So 24 divided by that answer is 30.
And I know when that I love you.
Oh my god.
So d theta dt would be telling you how fast that angle of elevation is changing, and that would be in degrees per. We're in hours, I believe, here, right?
Yeah.
That would be 30 degrees. per hour.
Who left this mark? Yeah, mother. If I failed this test, it's because of that.
Right?
That's how we say
So, just one, and I wanted to do one with an angle, so you were used to doing a trigonometry one because those will show up too.
Uh-oh.
Okay?
Yay.